Hello everybody, welcome back to chemistry. Before we get started today on the molar mass of compounds, I highly encourage you to grab your purple periodic table as well as your notebook, and we'll get started with talking about how to do the molar mass of compounds. Now, our first thing we're going to look at here is we're going to look at just one molecule of the substance CH4. Now, CH4 is a molecule we can tell because there are two different elements bonded together, both a carbon and a hydrogen. Now, when we're looking at this CH4, the first thing we're going to try and figure out is the pieces that make up this puzzle. In one molecule of CH4, there is one atom of carbon, and there are 4 atoms of hydrogen, due to that little 4 in the little corner, as well as this C up here. Now, when we scroll down just a little bit, now it changed. It's not just one molecule, because when we are talking about the real world, we are rarely talking about one molecule or one atom or one particle at a time, right? All very similar terms, just depends on what you're talking about. Now, if I had 1 dozen molecules, you'll notice it says dozen, dozen, and dozen. And it kind of works out very similarly to what we're talking about here. If I have 1 dozen molecules of CH4, I'm going to have 1 dozen carbons, and I'm going to have 4 dozen H's, right? Similar just to the one molecule, almost exactly the same. The key thing here is that we are talking about just more than one at a time. And so we're kind of talking about this because we're going to start learning about this thing called the mole, okay? The mole, once again, is still just a bunch of particles. The ratio will not change though. As long as I have CH4, no matter what, if this is what I'm working with, for every 1 carbon that I have, there should be 4 hydrogens as well. And we're going to discuss this a little bit more when we come back on Monday about what a mole actually is. But 1 mole is really all just saying is that it's a very, very, very large amount of particles here. And so it's just looking at tons of them all at once, because that's how we see things in our real world, because there's lots of atoms that fit in a very, very little space. And so what if instead of saying this one, we said there was 4? Now, I still know that for every 1 carbon, there are 4 hydrogen. But what kind of changes in this situation is, well, what if this entire thing was multiplied by 4, right? I'm looking at the whole thing. What I would say then is I'd say, hey, for every 4 carbon, there would be 12 hydrogen. And it would be the same ratio, just for a larger amount of substance. I come down a little further. Now, the molar mass of CH4, we're talking about mass. We're not talking about the molecules. We're not talking about the atoms. We're actually talking about the periodic table. So if I look over there, I see my carbon. It's got its 6 protons, right? I would look at the mass at the bottom, and I'd notice that it's 12.01 grams. That's all I'm going to write in here. Oh my golly, that's the mass of carbon. Now, when I look at my hydrogen, like before, we said for every 1 carbon, there was 4 hydrogens. So the mass is going to be a little bit different for hydrogen. Here, I know I have 1 of my carbon atoms, which gives me 12.01 grams. Sorry for the mistake there, folks. And then I look over here and I see, 4 hydrogen. So how am I going to find its mass? Well, if each one weighs 1.008 grams, I just take that number multiplied by 4, and I should see that in the end, I will end up with 4.032 grams, okay? Now, then in total, if I'm taking my pieces, I know that this is the mass of my carbon and this is the mass of my hydrogen. To figure out the mass of the whole thing, I'm going to take my carbon plus my 4 hydrogens, which would be the same as saying 12.01 plus 4.032. And voila, I get 16.042 grams. Now, what if I had 2 of them? Just the same as before, right? We did our 2 times our 1C and our 4 H's. Same thing's going to happen here, except this time we're going to put in our mass, 2 times 16.042, and I will get that as a 32.084. Now, 0.1 moles of CH4. Now, what am I going to do this time? Now, when we're talking about this before, we always said you can't have 0.1 of a molecule, right? But in this case, we're talking about that huge gargantuan number, that's 6.022 times 10 to the 23rd, which means I can't have a portion of that. So I take my answer and I say, okay, my mass is 16.042 for CH4. This is my CH4. Just multiply that by 0.1 and I'll know how much that weighs. 1.6042. Then alas, we get to this last question. And nicely for you all, we talked about this just yesterday in our lab. If I'm trying to go from grams to moles, we see up here, hey, 1 mole is equal to 16.042 grams. So I'm going to take my total, 64.168 grams, CH4, throw her over a 1. Oh my God, I do not want grams. Grams starts going to go on the bottom. What am I going to change it to? This random unit mole that Miss Bussin keeps bringing up. I wonder what that means, right? That number up here. And then I'm going to say, hey, for every 1 mole, there's 16.042 grams. Spit out my answer. Oh my God, it's 4. Because what I did, I multiplied these two things together. I multiplied these two things together. And when I get my answer, I should see that in my calculator, I do 64.168 divided by my 16.042 to get 4. 4 moles of CH4. Now I scroll down a little here. Water. I want to find what the mass of the water is. To do a question like this, what you would need to do is you'd say, I've got H2O. H2O, I want the mass of that. So let's figure out its pieces. It's made of hydrogen and it's made of oxygen. I can't find H2O on the periodic table, but I could certainly find H and I could certainly find O. I'm going to try and figure out how many of each there are. There are 2 H's. There is 1 O. I'll look at my periodic table. Hydrogen's 1.008. Oxygen's 16. I get 2.016. and 16. Take these two things, add them together, take my pieces, make my whole, and I'd see my total mass is 18.016 grams. Now, we just talked about this before. This number, at some point, we're going to talk about how this is called their molar mass. And so if you look at your homework, you'll notice that some of their units are looking like this. That's because it's relating back to that mole we talked about above. But I just need you to know how to add these two things together to get the total mass. We'll talk more about moles on Monday. I scroll down then. Okay, let's do one more together and then we'll move on. I encourage you to pause the video and see if you can do this by yourself or at least get it started and then join me again. Now, I see Al2SO4. I have Al, I have S, and I have O. When I'm trying to figure out how many each of these are, I notice there's like these parentheses in here. What does that mean? Now, similar to math class, if you had like 2 times A plus B, what you would think is, distribute my 2 and then I simplify, right? Same thing's actually going to happen here. I'm going to distribute this 3 to both of them. So I notice there's the parentheses, I notice the aluminum's outside of the parentheses, and I see this 2 right here. I have 2 aluminum. Now I look over, sulfur, it's in this parentheses. So before I would have said, there's just 1 of them. But once again, I'm going to distribute this 3. So 1 times 3, I have 3 sulfur. I look at my oxygen. There's 4 right here, this 3 on the outside. 4 times 3, I have 12 oxygen. And then I'm going to take a peek at my periodic table, look at their masses. Aluminum. Aluminum's mass is 26.98 grams. Sulfur's is 32.06, and oxygen's 16. Throw those into my calculator. Let's see if we can get this all calculated out. If I do 2 times 26.98, I'm going to get 53.96 grams. If I do 3 times 32.06, I'm going to get 96.18 grams. And then I go to my oxygen, 12 times 16, I get 192 grams. Take my pieces, add them together. My total mass then would be 342.14. Now, as I went through this, you might have said, Ms. Bussin, what about sig figs? Well, because these are all constants for my purple periodic table, I'm going to use the full number, but I'm not going to worry about rounding. They're all constants. They came from the table. So then this would be my answer. That is the molar mass of aluminum 2 sulfate. Have a great day, team.